So our next couple of questions, what we're asked to do is to find the graph here, and then also to find some asymptotes. So over here we've got the equation of the graph, this thing here. What we're trying to do, so it's not in our standard form that we're dealing with, but what we're trying to do is still got to kind of go with the information we've got. All these have some sort of turning point kind of thing. Remember, our turning point form is y equals a x minus h all squared, all squared plus k. That's what ends up there. I don't know why it keeps doing this. Maybe because it doesn't know what a is. Let's delete that and delete that. Now we know that we have -3 and -16. So as a result of that, we're going to have y equals a x plus y equals a x plus 3 all squared minus 16. Of course, that doesn't work. So we know we've got 16x plus 6 doesn't work. So this is what it ends up being here. We're going to delete that because a may as well be squared. So that's what we've got because of the fact that we've got a turning point here at -3, -16, -3. Sorry, plus 3 means it's -3, and 16, -16 there. Now, if x equals 0, then we've got a value there of -7. So what we'll do is we'll say we're going to solve this where x equals 0 and it equals -7. It's our y-intercept. We're solving that for a. Tell us that a, oh no, can I just solve that? That's incredibly frustrating. Okay, we'll have to solve it manually. So basically what we've got is that we know that 0 plus 3, this part here, 0 plus 3 squared is 9. So we're saying solve 9a, because I'm not doing times. That's why. Putting the times, thinks there's a variable called that. There we go. A equals 1 or a equals -1. Well, looking at our graph, it's got to equal 1 because of the way that the graph works here. So from there, we know that we normally write it in the form of, like I said before, and that's why it was doing that. I wonder if anyone picked that up. We know it's written in that form, but we know that it's a 1. So we end up with this here, y minus 16, x plus 3, y minus x plus 3 plus 16. It would have to be, no, it's not that either. My 6 doesn't work. So because this is the form that we've got, and because of what we've got here, we've got y minus 16 equals that, so we could bring that over to that side. It'll have to be y plus 16, doesn't work. Y minus plus, so it's got to be this one here. So it ends up with B. Last one along, we're looking for equations of asymptotes. What we do, my advice is just to graph them. So put them in, we graph them, we say we are doing that divided by that. Over here we've got 2x plus 5, I think it is. 2x plus 1. And we've got 3x plus 5. Let's just check that. 3x plus 5. Let's graph that. We've got an asymptote here. It looks like we are approaching 2 over 3. 2 over 3. Check that. Let's say that's our asymptote. 2 over 3. X equals 2 over 3. and our y looks like it's going to be negative 2 or negative 1. I'd say negative 5 over 3. That's what oh no, it's negative, that's positive. So we've got 2 over 3, 2 over 3, 2 over 3, 5 over 3, negative 2 over 3. Yeah, it's got to be at that one because it's the only one we have a negative y. Oh, sorry, no, my mistake. Y asymptote of 2 over 3, so it's either A or A, B, or C. And then we've got a negative y asymptote of 4 over 3, so it's got to be this one. So negative 4 over 3 translates to this, 2 over 3 translates to that. So we end up with B for that question.